A single machine weighing 6,000 tons pours molten aluminum at 700 degrees Celsius and in just 90 seconds creates what used to take 70 separate metal parts, 300 robots, and 1,600 welds to assemble. This isn't science fiction. This is happening right now inside Tesla's factories. And what you're about to witness is going to completely redefine everything you thought you knew about how cars are made. While the rest of the automotive world is still building vehicles the same way Henry Ford did over a century ago, Tesla has torn up the rule book and created something that looks like it came from 50 years in the future. Hey everybody, and thanks for tuning into our channel. My name is Joachim. The future is now, and we are here to explore and reveal all the latest and greatest technological breakthroughs from around the world. Be sure to subscribe to make sure you don't miss out on our daily uploads. Now let's dive in. Imagine standing at the entrance of Tesla's Gigafactory in Austin, Texas, or Berlin, Germany. The building itself is massive, stretching across millions of square feet. But here's what's truly mind-blowing. Unlike traditional car factories that require enormous assembly lines stretching in straight paths for hundreds of meters, Tesla's new manufacturing philosophy is completely different. They call it the Unboxed process, and it's about to change everything you know about how vehicles come together. But before we dive into the details, you need to understand something fundamental about how Elon Musk thinks about manufacturing. Most car companies see the factory as a tool to build cars. Elon sees the factory itself as the product. He calls it the machine that builds the machine. He's even referred to his vision as the alien Dreadnaught, a factory so advanced, so automated, so far beyond current technology that it would look alien to anyone from our current era. And when you see what's actually happening inside these facilities, you'll understand why those names aren't just marketing speak. They're an accurate description of what Tesla is building. Think about how cars have been made for the past 100 years. A metal shell, essentially a box, rolls down a long assembly line, and workers and robots struggle to install components through tiny door openings and limited access points. It's slow, it's inefficient, and it requires massive factory space. But what if you could build a car like you build with Lego blocks? What if, instead of forcing everything through narrow openings, you could assemble major sections simultaneously and then bring them together at the end? That's exactly what Tesla's doing, and the results are staggering. They're projecting they can reduce factory space by 40%, cut production costs in half, and build vehicles 25% faster than traditional methods. Can you imagine cutting your factory footprint nearly in half while producing more cars? That's the power of thinking differently. That's the power of building the machine that builds the machine. Let's start our journey at the heart of this revolution, the casting area. Walking into this section of the factory, you're immediately confronted by machines that look like they belong in a science fiction movie. These are the Gigapress machines, and they're the largest die casting machines in the world. Standing several stories tall and weighing between 6,000 and 9,000 tons, these mechanical giants are performing what seems impossible. Here's where it gets crazy. Traditional car manufacturing uses stamping presses to create dozens or even hundreds of individual metal parts. Those parts then need to be precisely positioned and welded together by armies of robots. For the rear underbody of a conventional vehicle like the Model 3, you'd need 171 separate metal pieces. Do you know how many pieces Tesla uses for the same section in the Model Y? Just 2. A single massive aluminum casting replaces 70 parts and eliminates 1,600 weld points. Watch as raw aluminum ingots are loaded into the furnace. The metal melts at 700 degrees Celsius until it becomes a glowing liquid. Then, with incredible force, this molten aluminum is injected into enormous molds. The pressure is so intense, it's like squeezing the ocean through a garden hose. Within 90 seconds, the aluminum cools and solidifies into a perfect structural component that would have taken hours to assemble using traditional methods. The genius here isn't just about making one big part instead of many small ones. It's about what this enables downstream. Because Tesla eliminated 70 parts from the rear underbody casting alone, they were able to remove 300 robots from the assembly line. Think about that. 300 fewer robots needed because one machine does the work more efficiently. That's not just innovation, that's revolution. This is what Elon means when he talks about the machine that builds the machine. Every improvement to the manufacturing process makes the entire system exponentially better. But here's the question everyone asks. How do you maintain quality with such massive castings? What if there's a defect? Traditional thinking says smaller parts are easier to control. Tesla's answer is brilliant. Their quality control systems use advanced AI and machine learning to monitor every single casting in real time. Sensors detect even microscopic imperfections, and the system automatically adjusts parameters for the next casting. The result is that defect rates are actually lower than traditional multi-part assemblies. Now let's move to something even more fascinating. As we walk through the factory, you'll notice the ceilings are unusually high. Why? Because Tesla isn't just thinking in 2 dimensions anymore. They're using 3-dimensional space in ways traditional factories never imagined. Conveyor belts run along the ceiling, transporting tools and components above the main floor. The production lines themselves aren't the straight assembly lines you're used to seeing. They curve in S shapes, with autonomous platforms moving components exactly where they need to be, exactly when they need to be there. This is the alien Dreadnaught starting to take shape. A factory that moves and thinks in ways that would seem impossible to traditional manufacturers. And speaking of autonomous, let me show you something that's going to completely blow your mind. Right now, in these factories, Tesla is testing something that sounds like it came straight out of science fiction. Working alongside human technicians, you'll see robots that look remarkably human. These are Tesla's Optimus humanoid robots. And what Tesla is planning for these machines is beyond anything you can imagine. Standing 5 feet 8 inches tall and weighing 125 pounds, these robots can walk, grasp objects with surprising dexterity, and adapt to unexpected situations, using the same AI technology that powers Tesla's self-driving cars. They're currently in testing phases within Tesla's facilities, learning to handle batteries, move components, and perform the repetitive tasks that factories require. But here's where things get absolutely insane. Next year, Tesla plans to produce 1 million Optimus robots. 1 million. Then they're scaling to 10 million robots per year, then 100 million per year, and eventually, potentially billions of these humanoid robots annually. Can you wrap your head around what that means? We're not talking about thousands of robots, we're talking about billions. But wait, it gets even crazier. These Optimus robots will be able to assemble more cars. And here's the part that should make your jaw drop. They'll be able to assemble more Optimus robots. Think about what that means for just a second. A robot walks off the assembly line, and immediately it can start building the next generation of robots, which will then build more robots, which will build more robots. This is exponential growth on a scale humanity has never seen before. It's not linear, it's not even geometric. It's a self-replicating cascade of manufacturing capability. The first million robots help build the next 10 million. Those 10 million help build the next 100 million. And each generation comes online faster than the last because there are more workers building them. Imagine a factory where robots are building cars during the day and building more robots at night. Or better yet, imagine a factory that's building both simultaneously, 24 hours a day, 7 days a week, 365 days a year, with no breaks, no vacations, no sleep. Just continuous, relentless production scaling at an exponential rate. This is the true meaning of the alien Dreadnaught. Not just a factory that's more efficient than anything we've built before, but a factory that can replicate itself. A manufacturing system that grows, that evolves, that multiplies. It's like giving the factory the ability to reproduce. And the trajectory this creates is pretty freaking wild. We're talking about a future where the limiting factor in manufacturing isn't human labor, isn't even factory space. The limiting factor becomes raw materials and energy. That's it. Think about the implications. If Tesla can produce billions of humanoid robots per year, and those robots can assemble vehicles, what happens to the cost of a car? What happens when labor costs approach zero? What happens when a factory can produce a vehicle every 5 seconds, staffed entirely by robots that were themselves produced in that same facility? The economics of manufacturing get completely turned upside down. But let's follow a vehicle through its journey. After those massive front and rear castings are created, they move to the stamping area, where the remaining exterior panels are formed. These are the parts you actually see on the car: the doors, hood, fenders, and side panels. High-speed stamping presses shape aluminum and steel sheets in just 4 to 5 steps. The precision here is measured in microns. We're talking about tolerances smaller than a human hair. Here's where the Unboxed process really shows its power. Instead of immediately welding all these parts onto a single body shell, Tesla manufactures different sections of the vehicle simultaneously in dedicated areas of the factory. The front section is assembled in one area, the rear section in another, the battery pack and floor structure in a third area. All of this happens at the same time, in parallel rather than sequentially. Think about what this means. In a traditional factory, if there's a problem at station 15 on the assembly line, the entire line stops. Every station before and after grinds to a halt. Production workers at Station 1 have nothing to do because Station 15 is backed up. It's like trying to move an army across a bridge in single file. One person stumbles and everyone stops. Tesla's approach is different. If there's an issue with the rear section assembly, the front section and battery pack teams keep working. No single bottleneck stops the entire factory. Now we reach what might be the most impressive part of the process, the marriage station. This is where all those separately assembled sections, the front megacasting, the rear megacasting, the battery pack, the interior components, finally come together. Massive robotic systems lift these multi-ton assemblies with millimeter precision and align them perfectly. In traditional manufacturing, this would require dozens of fixtures and hundreds of bolts and welds. Tesla does it with structural adhesives and a handful of precisely placed fasteners. The battery pack itself is an engineering marvel. It's not just an energy storage device, it's a structural element of the vehicle. The pack serves as the floor, improving rigidity while lowering the center of gravity. For the Model Y produced in Berlin, these battery packs contain thousands of individual cells. And here's something fascinating. The entire pack, including all its electronics and cooling systems, is installed as a single unit in a matter of minutes. And now, get ready for this. Tesla's Berlin factory has become so efficient that they're now producing vehicles at a pace that seems physically impossible. A complete vehicle rolls off the line every 30 seconds. Let me repeat that because it's so insane it's hard to believe. Every 30 seconds, a fully functional electric vehicle, complete with autonomous driving capability, batteries installed, software loaded, quality checked, and ready to drive away. That's 2 cars per minute, 120 cars per hour, nearly 3,000 cars per day from a single production line. Think about what you can do in 30 seconds. That's barely enough time to tie your shoes. In that same time, Tesla has assembled a 2-ton electric vehicle with over 10,000 parts, 1,400 weld points, 60 meters of structural adhesive, 130 self-piercing rivets, a battery pack containing thousands of cells, 4 electric motors for all-wheel drive models, a complete interior with seats and dashboard, and all the sensors and cameras needed for self-driving. How is that even possible? As the vehicle moves through final assembly, approximately 1,000 employees per shift currently install wheels, seats, windows, and perform the final connections. But here's what's remarkable. As those Optimus robots scale up production and begin working in these factories, the ratio of human to robot workers will shift dramatically. But Tesla isn't eliminating human workers. Instead, they're elevating what humans do. Workers from over 150 nations, many with no previous automotive experience, will focus on skilled tasks that require judgment, creativity, and problem-solving. The robots will handle the repetitive, physically demanding tasks. Humans will handle strategy, innovation, and complex decision-making. The paint shop deserves special mention. Unlike traditional paint shops, where vehicles are fully assembled before painting, Tesla's modular approach means individual panels and sections can be painted separately before final assembly. This creates better paint coverage, reduces waste, and allows for more efficient quality control. Every surface is mathematically optimized using computational fluid dynamics to ensure even paint distribution. The result is a flawless finish that traditional methods struggle to match. And here's something most people don't realize. Every Tesla factory runs on 100% renewable electricity. The Berlin factory alone has 9 megawatts of solar panels installed on the buildings and parking structures. They're not just building electric vehicles, they're manufacturing them using clean energy. The entire production process, from raw materials to finished vehicle, is designed to minimize environmental impact. But perhaps the most revolutionary aspect of Tesla's manufacturing isn't any single technology. It's the philosophy of continuous iteration. This is where the concept of the machine that builds the machine really shows its power. Unlike traditional automakers, who design a vehicle, tool up production, and then build the same design for years, Tesla treats manufacturing as a software problem. They're constantly updating, optimizing, and improving. There are no model years in a Tesla factory. Instead, improvements are rolled out every few months. A car built in January might have subtle improvements compared to one built in December, all while using the same production line. The factory itself is constantly evolving, constantly learning, constantly improving. That's why Elon calls it the machine that builds the machine. Because every optimization to the factory makes it more efficient at building the next generation of improvements. It's a self-reinforcing cycle of innovation that traditional manufacturers simply cannot match. The data flowing through these factories is staggering. Sensors throughout the facility monitor everything, from the temperature of casting molds to the torque on every bolt. Advanced AI systems analyze this data in real time, predicting potential problems before they occur and automatically adjusting parameters to maintain quality. It's Industry 4.0 in its purest form. The factory itself is learning and improving constantly. And this is just the beginning. Tesla's latest patents reveal they're working on even more radical improvements. Their new battery manufacturing process, using dry electrode technology, could cut battery production costs by another 30 to 40%. They're exploring die casting machines that could be even larger, potentially making 5 castings simultaneously in a single 50,000-ton press. But here's where things get absolutely wild. Elon Musk recently revealed Tesla's ambition for the Cybercab, their fully autonomous robotaxi. When the new factories designed specifically for the Cybercab come online, Tesla is targeting a production rate of 1 vehicle every 5 seconds. Not 30 seconds, 5 seconds. Can you even comprehend that? In the time it takes you to read this sentence, 3 Cybercabs would roll off the assembly line. To achieve speeds like that, Tesla is pushing Gigacasting to its absolute limits. Musk has talked about potentially building die-casting machines so large they could produce multiple castings simultaneously. Maybe 50,000-ton presses that make 5 castings at once. Some engineers think he's being provocative, but knowing Tesla's history of making the impossible routine, don't bet against them figuring it out. They're literally asking, what are the limits of physics for die-casting machines? And then setting out to find those limits. This is the alien Dreadnaught in its ultimate form. A factory so advanced, so optimized, that it produces vehicles faster than seems physically possible. And when you combine that 5-second production rate with billions of Optimus robots working around the clock, you start to see a future that's almost impossible to comprehend. A future where manufacturing abundance becomes the norm, where the question isn't, can we build it, but what should we build? Where scarcity in manufactured goods becomes a thing of the past, because the production capacity is essentially limitless. The implications of what's happening inside these factories extend far beyond Tesla. Legacy automakers like Toyota, Ford, General Motors, Nissan, Hyundai, and Volvo have all either purchased Gigapress machines or announced plans to adopt large-scale casting. The Chinese automakers NIO, Geely, and Xpeng are already using gigacasting in production vehicles. Tesla didn't just innovate for themselves. They're forcing the entire industry to rethink a century of manufacturing orthodoxy. But here's the bigger question. If Tesla can produce a vehicle every 30 seconds today and is targeting every 5 seconds tomorrow, while simultaneously scaling to billions of humanoid robots that can build both cars and more robots, what happens when this technology spreads to other industries? What if construction used billions of robots? What if we could build entire cities with the same exponential scaling? What if every form of manufacturing adopted this self-replicating approach? We might be witnessing the beginning of a manufacturing revolution that changes the entire foundation of human civilization. The future Tesla is building isn't just about electric vehicles. It's about reimagining how we make things, period. From humanoid robots that can replicate themselves, to AI systems optimizing every aspect of production. From massive single-piece castings to modular assembly techniques that produce a car every 30 seconds. Tesla has created a blueprint for 21st century manufacturing. And they're proving it works, producing over 650,000 vehicles per year from Fremont alone, with global capacity exceeding 2 million vehicles annually. As you look at what's happening inside these factories, one thing becomes crystal clear. The future of manufacturing isn't coming, it's already here. It's happening in Austin and Berlin and Shanghai and Fremont right now. And if Elon Musk gets his way with the Cybercab factories and the Optimus robots scaling, we're going to see production capabilities that would have been considered science fiction just a few years ago. 1 vehicle every 5 seconds. Billions of humanoid robots per year. Each robot building more robots. Each factory essentially able to replicate itself. At that rate, a single factory could produce over 6 million vehicles per year. But with billions of robots, the numbers become almost meaningless because they're so large. We're talking about the potential to produce hundreds of millions or even billions of vehicles if the demand existed. But more importantly, we're talking about the ability to redirect that manufacturing capacity to whatever humanity needs most. Housing, infrastructure, space exploration equipment, medical devices. Anything that can be manufactured could potentially be produced at scales we've never imagined. Now you understand why Elon calls these facilities the machine that builds the machine and the alien Dreadnaught, because that's exactly what they are. Self-optimizing, self-replicating manufacturing systems that are redefining what's possible in industrial production. The factory isn't just a building where cars are made. The factory is the innovation. The factory is the breakthrough. The factory is a living, growing organism that can multiply itself. And the exponential trajectory this creates is pretty freaking wild. We're not talking about gradual improvements anymore. We're talking about explosive, cascading growth that compounds on itself year after year after year. The only question is how quickly the rest of the world can catch up, or if they even can. So what technology that amazes you the most? We'd love to hear from you. And if there are any technologies you'd like us to cover in the future, let us know.